Hi everybody. Next we are going to discuss about the ARM architecture. So it is a very important one because the worldwide we are using the ARM processor. We are producing around 250 billions of chipsets so far we are producing, and we can give to the country and we are given to the society, and especially it's used for the smartphones and wearable devices. Mostly the 95% of component we are using the ARM processor. The remaining 90% of product we can use in the wearable devices. So mainly it's focused the energy and the consumption and the scalability. These are the main thing. So energy consumption plays a major role. We already discussed the many topics, the electronic and communication, the electronic devices, the ARM processor, the tiny devices, and energy efficiency plays a major role. Based on that, we can able to use the other peripheral devices. This is the main chips of the ARM architectures mainly we are using here. And the focusing how we can producing the fundamental things, and how the beneficiary and how the brief history about the ARM architecture in the sense. The 1990s itself we are founding the formation of chipsets. I mean that's called as a risk machines. Of that we are producing the basic business model. The business model in the sense we are producing the property of manufacturing chips. And then the partners, the partner of ecosystem, where we are using the Qualcomm, Apple, and Samsung's. Mainly they are producing the SoC, the system on chip. Everything will made in a single chip, that is called as a system on chip. We are made in a single chip and we can fix in the device, that is called as a system on chip. That's the start step. The remaining thing, the risk peripherals, it's the emphasis of the instruction computing of risk, that is the reduced instruction set of computing, that is called as a risk. So automatically we can able to do which a main process and very quick manner. That is the main thing. And the other thing of ARM architecture fundamental, we are redirected reduced, that is we say that is a informal, that is a formal and informal. Mainly the informal memory where we are mainly using in that. The informal memory we can store and we can load the information, that is called as informal memory. And the formal memory is also the addressing modes. We can able to address, we can able to store the information in the particular places. We can relocate and we can collect the information, that is informal process. And the simple length of instruction set, the instruction set is a very simple. And also the more registers we can use here. And also it's a regular usage of thing we are using, that is a ARM fundamental architecture we are using here. And the mainly the ARM fundamentals, the risk philosophy and the load of architecture, instruction set and register files we are using here. And it will be a simple one, and it's a full length, that is called as 32 bit of 32 or 64 bit of instruction set. And the second thing is a load or store architecture mainly we are using. It's operating the registers and it will be directly to the stored in the memory. And the instruction set mainly we focus on that is a 32 bit of instruction set with that is a two things, that is a thumb 1 thumb 2 we are using. One is 16 bit, another one is a 16 bit or 32 and 32 bit of instruction set we are using ARM architectures. And mainly the registers file we are using general purpose, mainly is a 32 bit of instruction set we are using here. And we have the drivers of ARM process family. We have this Cortex A, Cortex R, and Cortex M we are using. Mainly the high performance application we are using the Cortex A, and the real-time process and the safety critical systems we are using the Cortex R, and other microcontroller embedded IoT applications we are using the Cortex. And these are the three main applications of we are using here. And ARM control processor we are using the high performance, mainly we are using the high end of smartphones, that is a Android phones. And the scenario 2 is the airbag system, where autonomous vehicle, that automotive vehicle of airbag system we are using. And reliability, fast response, which is suitable, that is ARM core or other. Scenario 3 is a smart light bulb we are using. That's a designing of low cost and low power of smart light bulb, which will be used in the which one is best. This is the your activity, you can find it. So you can think and you can find. And next one is a key features and architecture of architectures, mainly the pipelining, memory management unit, interrupts and caching, and the trust zone. That's the five things are the key architecture of features. The pipelining mainly the instruction set to execute the stages in very effective manner. That is called as a pipelining. And the memory management is nothing but the memory of virtual memory in the essential for operating system. That is the main thing of memory management. It will manage the things. And the interrupts is effectively handling the external event and respective things. And the caches are mainly is on chip, that memory of L1, L2 and L3 with very faster to access the information where we are stored in the memory unit. And the trust zone mainly the security sensitive and other execution of environmental we are mainly using. And this is the assessment question, that's risk meaning, and the cortex A instruction set and listen. We have to assess, we can get the information. And the answer for this question, this assessment answers, you can note it down. So first thing is we reduce the instruction set, and the smartphone will be high enablement we are using, and thumb instruction set we are using answer 3, and answer 4 is nothing but a fastest broadband ecosystem and the drivers implementation. We are reducing the manufacturing cost. These are the very important thing of the assessment. And ARM processor mainly we go for the licensing model to drive the computing of with the effective manner, and the ability to form the tiny sensors and supercomputer. That is the main thing of ARM architecture. It will be influence in the supercomputers. That's the main process of ARM architecture. And also innovation continues the shaping of the future technology. That is the main thing. Whenever you find a new devices, new component, it will be suitable for the future technology. The ARM architecture and ARM processor is mainly used for the future technology. That is a main advantage of ARM processor. Thank you.